Let's take a look at some sample problems on polynomials and factoring. And we begin with adding and subtracting polynomials. First thing we want to do in number 6 is distribute the negatives in front of the first and the third trinomials. So negative 1 times 8x cubed, negative 1 times x, and negative 1 times negative 3. I can just drop the parentheses here since the sign in front of it's positive, and I'm going to change the signs here, distributing the negative. Okay, now what we want to do is collect like terms, and the highest degree we have is the 2x cubed. Now negative 8x squared, x squared, minus 4x squared. So negative 12x squared plus 1x squared would be negative 11x squared. Okay, and now we'll do our x. Okay, negative 4x. And then finally our constant terms, we have a 3 and a 1, so that'll be a 4. Okay, in number 10 we want to apply FOIL. Y times y is y squared. Y times negative 9, negative 9y. Negative 3 times y, negative 3y. And negative 3 times negative 9 is positive 27. So if we collect our like terms, it should be a squared. It'll be minus 12y in the middle plus 27. Okay, now in this one, if you don't remember the shortcut for squaring, remember that you can do this, write the factor out twice, and then FOIL it. If you remember the shortcut, it's a little bit quicker. A squared minus 6ab minus another 6ab plus 36b squared. Okay, and by the shortcut, you square the first term, you multiply the 2 and double it, see what's happening there, and then you square the second term. So either way, you'll arrive at the same answer. Okay, in 22, we had a rather long polynomial. So I'm going to do this vertically. And I'm multiplying by k plus 2. Okay, first step is to multiply everything by 2, so 2k minus 6k squared, 24k cubed. I'm going to multiply everything by k, and I'm keeping my terms lined up. K squared minus 3k cubed, and then 12k to the 4th. Now I can add up the like terms. 3k, negative 5k squared, 21k cubed, that would be positive. And so there's our product. Right now we're going the other way. We're factoring. We want to factor out the greatest common factor. 2, negative 10, and 16, it would be a 2. P to the third we can take out of all of those. So we get p squared minus 10p plus 8. Okay, our next one is a little more complicated. We see a common factor of a plus 3, so we're going to take that out. That leaves us with 5 times a plus 3 squared minus 2 plus a plus 3. So we need to simplify what we have in the square brackets. This is going to be a squared plus 6a plus 9, again using the shortcut for multiplying it out. Notice again you could write a plus 3 times a plus 3 and FOIL it to get this answer. Okay, so we're going to have 5a squared plus 30a plus 45 minus 2 plus a plus 3. And we're almost there. We just need to simplify what we have in the square brackets. 5a squared plus 31a plus, let's see, plus 46. Because that's going to give us 43 plus 3. Okay. All right. And we're still factoring. This time we're factoring by grouping, so let's group them in pairs. I can take a 2 out of the first pair. I can take a minus a out of the second pair. Okay, and now we have m to the fourth plus 3 in common. And what's left over is 2 minus a. Alright, so that's our product. This one we're trying to do FOIL in reverse. So we know we'll have two binomials. Two numbers need to multiply to give us 12 and add to give us 8. So a positive 6 and a positive 2. Just think about the factors of 12. You can kind of list them out if you... And of course there's the one that works. Alright, this one we're supposed to factor completely, so we have to factor out an 8 to begin with. Minus 3h minus 40. Alright, can we factor this any further? We need to try. H and h. We want to see if we can come up with two numbers that will multiply to give us 40, but add to give us a negative 3. And let's see. 1 times a negative 40, 2 times a negative 20, 4 times a negative 10, 5 times a negative 8. Aha! So that's it. So plus 5 and minus 8. Okay, so that one required a couple of steps, taking out the greatest common factor and then factoring the remaining trinomial. Alright, our next one, we want to factor it. The leading term is not a 1, so we're going to multiply a and c, the leading coefficient and the last coefficient. We get a negative 30. So we need two numbers that multiply to give us negative 30, but add to give us, and that's a 1 in front of those. So it would have to be negative 5 and a positive 6. I think would do it. So we're going to rewrite the middle term, 3a squared minus 5am plus 6am minus m squared, and we'll do these in pairs. I'm going to move up here. We can take an a out of the first pair. We can take an m out of the second pair. Let's see. Oops. I goofed that up. That should have been a 30. So we could take a 5a out of that first pair, and that would be a 6a. Let me just start this one over. I totally botched it because I copied it wrong. Okay, this is 30a squared minus 5am plus 6am minus m squared. I forgot to bring down the 0 there. Okay, so we can take out a 5a. That leaves 6a minus 5m. Minus, we can take out an m, a positive m, it should be a plus, and that'll be 6a minus 5m. Shouldn't be a 5. Okay. So, what we have left Now the common is 6a minus m, and we're left with 5a plus m. Alright, now here we have a perfect square trinomial. The way I know that is the first term is a perfect square, the last term is a perfect square. If I multiply those together and double it, I get 40p. So I know this will be 4p minus 5, the quantity squared. Difference of squares, we're going to have t plus 8 times t minus 8. Okay, sum of cubes. We have r cubed plus 3 cubed. So the way we factor that is our binomial without the cubes on it. Then we square the first term, we take the opposite of the product, 3 times r, and then we square the last term. And that's it. Alright, here we have 2m that's cubed minus 3n that's cubed. So we're going to write it 2m minus 3n, that's our binomial. And then we're going to multiply these together and change the sign. It'll be 6mn square the first term before I do that. Then positive 6mn, then positive, we want to square the second term. Okay. Alright, now this is one that we're just given instructions to factor, and there's no common factor. I notice there's a fourth power and a second power, so this somewhat has the same format as the trinomial where the leading term is not, leading coefficient is not a 1. So let's try that method and see if that'll help us. So I get a negative 18, so I need two numbers that multiply to give me negative 18, and add to give me 7, and that would be a 9 and a negative 2. So I'm going to rewrite 6p to the 4th plus 9p squared minus 2p squared minus 3. And now I'm going to factor by grouping in pairs. I can take out a 3p squared. That would leave 2p squared plus 3 minus 1 times 2p squared plus 3. So that's the common factor now, 2p squared plus 3. Oh, and so it worked out. We did indeed factor that using that method. Okay, so that ends this group of problems.